Hey guys, welcome back to Calculus Universalis, and today we're going to go over 3.1 Implicit Differentiation. We're starting a brand new unit with topics of differentiation where we're going to finish off derivatives and finally complete what we need to know for calculus. So, let's get into it. What we're going to do today is implicit differentiation. So, what is implicit differentiation? Let's start off with this example. X times y equals 1. This can be simplified to y equals 1 over x. Now, what we want to do is find the derivative of this whole thing, right? And in order to do that, lots of times we're going to have crazy variables like z equals 1 over t or something. And we just learned product rules and chain rules. Each of these things is going to have a chain rule eventually. So if we did, let's just do, z and t over here on the side, right? I'm going to do z prime equals 1 over t prime. We're taking the derivative of both sides. That's implicit. Taking derivatives of both sides same time. So derivative of z is just 1, but you have the chain rule. What's the chain rule? Z prime. See, that's kind of counterintuitive, but what are we solving for anyway? Z prime. So really, it doesn't really matter. And then we're going to take the derivative of this, which is t to the negative 2, negative t to the negative 2. Alright, and that's our answer. Z prime equals negative t to the negative 2. But since we have these crazy variables, it's going to be times the derivative of t, or t prime. Now that was probably extremely confusing and didn't make any sense, but that's just a glimpse of where we're going to get into. So back to this example where we have xy equals 1. So when we have something like this, we're going to solve for y to make it easier on ourselves. So we're going to have 1 over x. Now let's take the derivative. That's what we just did. Y prime equals 1 over x prime, right? If we evaluated y prime, right, we're just going to get 1 times y prime. But since y prime is what we're solving for, we don't really need it. Since we're solving for y prime, we're going to have to multiply it by the chain rule. So it's just confusing, isn't it? So if you have y prime, you're going to take the derivative of y, which is just 1, right? So we're going to have a 1 times its chain rule, dy over dx. And that's going to equal, take the derivative of the other side. So we have x to the negative 1. It's going to be negative x to the negative 2, okay, times this chain rule, dx over dx. Sorry. And then this is implicit differentiation. So we're basically taking the derivative of this, and that's just how it is. And we're going to get a chain rule somewhere with the y. This is going to pop out, and this is what we need to have isolated on its own side. Now with this dx over here, what happens to that? Well, luckily enough for us, it cancels out to 1. So then we have our dy over dx equals negative 1 over x squared. And that's implicit differentiation. some may still be really confusing for you, but don't worry, we're going to do something where it's going to make a lot more sense. So I explained to you why we need to do it, in case we have crazy variables and we need chain rules to solve for certain things. And then I showed you an example. So I'm going to show you one more example. What if we have y plus sine of y equals x squared plus 1, and I ask you find dy over dx. How in the world are you going to start? Pretty simple. Take the derivative terms of x over here, take the derivative terms of x over here, and this is finally what I'm getting to, implicit differentiation. So the stuff I showed you before is a glimpse, but this is really it. And I should have went to this first because it makes more sense, but you're basically doing d over dx on both sides, just like this. The whole entire thing, taking the derivative with nothing there yet, no dy, no dx, just d over dx. And on this side, you're going to assume it's going to be dy. This side is eventually going to be dx. But for now, that's all we have. Now let's evaluate this. So the derivative of y is 1. Well we have our chain rule. Times dy over dx plus derivative of sine of y is cosine of y. Oh no, we have another dy over dx. Chain rule. Over here, 2x plus 0. And, can't forget it, even though it's redundant, dx over dx. And this is just plus 0. There's no chain rule. This cancels out. But these most certainly do not. And since I asked you to find this, you're going to have to find out how to isolate dy over dx. So you can pause the video, try it. But now I'm going to hop straight to it. So this is going to become factored out dy over dx. So then we can isolate it finally. And we're going to have 1 plus cosine of y equals 2x isolated dy over dx equals 2x minus 1 minus cosine of y, and that is your final answer, and that's how you implicitly derive your functions. Oh my gosh. Yep, I was just... I made a mistake. Not too much though. It's going to equal 2x. This is going to be a divided thing. This is going to be divided, and you have dy over dx.